Welcome back to another calculus lesson. This is Mr. Thompson. We're looking at the problem set for section 2-4. I'm going to go ahead and look at a series of pretty simple problems, as long as you understand the terminology. We're going to look at 11 through 15. So let's see, number 11. And all of these problems, it says to sketch a graph of a function that has the indicated features. Basically, you just need to sketch a simple graph. 11 is continuous at x equals 3, but has a cusp there. So you just got to remember that a cusp is a sharp turn. So it could be something like this. That would be a cusp. Now it could be 100,000 infinity different kinds of functions that you can draw as long as it has a cusp there. Number 12 is continuous at x equals 4 and is smooth there. Smooth is the opposite of a cusp. 1, 2, 3, 4. So this can be pretty much any line, any function that goes through there and continues. That would be a function that is smooth there and is continuous. 13 has no value for x of 5, but has a limit as x approaches 5. No value, but still has a limit. That means we have a removable discontinuity at 5. Something like that. 14 has a value for f of -2, but has no limit as x approaches -2. No limit, but having a value that can be a step discontinuity. So at -2, I should probably mark these as 4, 3, and 5. We have a step discontinuity. I probably should have made my graph look better, but that works. Now, let's look at a couple more so that you get the idea. Number 15 has a vertical asymptote at x equals 6. 1, 2, 3, 4, 5, 6. Vertical asymptote means it never touches it. Something like that. Vertical asymptote. So, pretty simple. Let's look at one last one, number 16. Has a value for f of 2 and a limit as x approaches 2, but is not continuous at x equals 2. So, has a value for f of 2 and a limit as x approaches 2, but is not continuous at x equals 2. So we have to think about what that could be. That could be a removable discontinuity. At 2, I'm going to say this is my line, that's my function, however I'm going to put a dot up there. That would be a removable discontinuity. It has a limit as x approaches 2, but is not continuous at x equals 2. So that works. Now, I could go over the rest in that little section, but they're all pretty much the same thing. You just got to understand the terminology and fit them in with an example from one of the kinds of problems we've seen. So that's it for section 2-4. I'm going to go ahead and take a look at section 2-5.